Okay, so let's get started. We're going to be taking a look at setting up and working with our idle control with drive-by-wire in our training tutorial here using our Motec M1 programming. Now, we've already discussed idle control and some other forms of idle control, including a stepper motor, a idle control duty cycle controlled solenoid, as well as mechanical-based idle control. Drive-by-wire is by far the best and easiest way to control our idle and, in my opinion, just overall operation of our engine. Definitely like to go drive-by-wire whenever possible. So we're going to be discussing all of the details in order to get the drive-by-wire control calibrated correctly for idle conditions, and then we'll take a look at some of the other parameters and variables that we have to go along with the idle conditions within the drive-by-wire control. It's very straightforward to configure and set up, as we will find in this training module. Let's first jump from our field tuning page here under our tuning area that's in the workbook I provided for our training course. We're going to move over here into our fifth window called idle tuning. In our idle tuning area here, we have a lot of different tables, a lot of different things we can program. Right now, we have set the idle control mode to disable. So in this case, we have no idle control integrated on the Motec. We need to turn this on, and then because we have drive-by-wire enabled, it's going to automatically assume that it's going to control the drive-by-wire throttle blade opening for idle control. We do need to go here under actuator and specify a specific condition for the throttle aim. We'll talk about how this value integrates into the whole control routine, but we'll find that if we're drive-by-wire, Motec's automatically assuming that we don't have an idle solenoid or stepper motor to deal with, and it's directly driving the throttle blade to get the airflow to come into the engine to reach the certain desired level of engine speed that we're programming here in our idle aim main. Now, we are at this point configured for the drive-by-wire. So we've set up the Excel pedal position sensors. We've set up the throttle position sensors in the drive-by-wire throttle body. We've set up the servo control in the control routine. So let's jump in here. And then we've also set up our pedal translation, and we've also set up our throttle area percent. Now, our throttle area percent, real quickly here, this is going to be essentially the effective area of our throttle blade. This will change based on different size throttle bodies. Essentially what we're finding here is that it's going to be looking up a throttle blade opening versus either the effective area, or you can also think of this as the flow across the throttle blade. This table should be populated specific to the throttle body you're working with. We've discussed that in our last training module. However, most cases, I don't have this information available. So we typically just set our throttle area percent here in a linear fashion. And we set our throttle pedal translation here, table here, to be able to translate the pedal to plate relationship. Normally, this would be able to linearize a non-linear type of airflow across the throttle blade, but in this case, I don't have the information available, so I've made this linear. The reason why I'm pointing this out in terms of our throttle area percent table is that we want to make sure this table has been set before we do any idle control tuning, because our values that we do a lookup here in the throttle area percent will affect the throttle blade opening in the idle control. So in this case, I've went in here, I've linearized this table. Any pedal plate relationship I want to go ahead and change, I'll do that in the translation table here, as we discussed in the last training module, which now allows me to move into the idle control and being able to set up my feed forward table, all based around this throttle area percent table. This essentially will drive the entire system, including the pedal plate relationship as well as idle conditions. So I just wanted to mention that this table should be configured before you do any idle tuning, or you'll have to go back in and deal with setting up your feed forward value, table values for idle control, and getting all that sorted out if you do make changes to our table here. So let's jump in back to the idle area here. So going into tuning and into idle tuning. The first thing we're going to talk about here is going to be our throttle aim. Now the throttle aim, we see there's a maximum value. This drives the entire idle control. So this is setting the upper limit of our throttle blade opening. This is the most amount of slow path airflow that we're allowed to bring in during this idle control routine. So anything that's going to be trying to command anything higher than, let's say, the value here, if we put something like 20%, the throttle blade will not open any further beyond this point. So the maximum here is also referenced when we're talking about something like our feed forward duty cycle table here, or something like our cranking idle mass flow table here. This will use either 0 to 100% of whatever this maximum is going to be. So we can think of this just really simply here. If I put a value of 10%, just to keep this simple, 10% is the maximum throttle blade opening I'm allowed to run at. Then 100% within a table here is 100% worth of this 10% maximum. If I had a value here of 50%, it would be then 5% of the maximum. Same's gonna go here for the feed forward table. If I had a value here of something like 100%, it'll use 100% of that 10% maximum throttle blade opening. 50% then would call out then 50% of this 10% throttle blade opening, which would then be 5%. So this sets the limit. It also sets the overall scalar for the idle control. So what we have to do here in terms of the maximum, you may have to go and experiment with this in terms of the maximum value to put in, but typically 10 to 15% are normal values for most engines. If you're finding, for example, during your idle control tuning that you're seeing as you're going and trying to populate your feed forward table values here, for example, if you're finding that at higher idle aims or the idle target, the closed loop, what we're basing around the entire control here, the closed loop idle that we want to go ahead and idle at, if you're finding that you're getting up to something like 80 or 90% in the table here, and you're still really not reaching your idle aim value, that means you need to come in here and open up your maximum and put it to a higher maximum value. So the throttle blade will actually open more. You may need more airflow or slow path to influence the engine's torque to increase the idle speed to reach the design.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.